You've driven on roads that look perfect, and then fall apart in a few years. And then you hear something almost unbelievable. There are Roman roads that have survived for nearly 2,000 years. Not perfectly intact everywhere, not all still in use, but present enough to embarrass modern infrastructure. Stones still locked in place. Foundations still holding. Roads still visible from the air like scars across Europe. So the obvious question hits like a challenge. What did the Romans know that we don't? And the honest answer is more interesting than the myth. Because the secret of Roman roads is not a single miracle ingredient. Not magic concrete, not a lost formula hidden in a forgotten scroll. The secret is a system, a brutal, practical engineering philosophy built around four ideas that modern people often underestimate. Water is the real enemy, compaction is everything, layers matter more than the surface, maintenance is part of construction, not an afterthought. Roman roads weren't built to feel nice under your feet. They were built to survive marching armies, wagons, weather, and time, and to do it across an empire where control depended on movement. Rome didn't build roads as a convenience. Rome built roads as power, because an empire without roads is an empire that can't respond. It can't move troops quickly to crush rebellion. It can't supply frontier forts. It can't tax efficiently. It can't trade smoothly. It can't project itself into distant provinces. Roads were Rome's circulatory system. If the roads failed, the empire's limbs went numb. So Rome invested in permanence the way modern states often invest in speed and cost cutting. Now here's the twist. When people say engineers still can't replicate Roman roads, what they usually mean is not that modern engineering lacks knowledge. Modern engineers understand drainage, layers, compaction, and materials extremely well. In many ways, modern road science is far more advanced. What we often don't replicate is the Roman priority. We don't build most roads to last centuries because most modern roads are built under a different economic logic: faster construction, lower upfront cost, easier repair, and design around cars and heavy trucks with predictable maintenance cycles. We build systems that are efficient for modern budgets and modern traffic. The Romans built systems that were efficient for imperial control and long-term durability. Different world, different choices. But even with that said, the Roman method is still shocking because it was simple and ruthless. Start with route selection. Roman roads are famous for being straight, and that's not just because the Romans loved straight lines. Straight lines shorten travel time and simplify logistics, but they also show something deeper. Roman survey culture was professional and disciplined. They measured. They planned. They controlled gradients as much as possible. And when a straight line wasn't feasible, because of mountains, marshes, or rivers, they engineered solutions: cuttings, embankments, bridges, causeways. They treated route choice like military planning, because it was. Now consider the enemy that destroys almost every road faster than any traffic load: water. Water seeps into gaps, freezes, expands, loosens stone, undermines foundations, and creates the slow death of potholes and cracks. Modern roads fail when water gets into places it shouldn't. Roman roads were designed to keep water moving away. That's why Roman roads were often raised. They were built on an embankment, an agger, with a crowned surface, so water would run off to the sides rather than pooling. Ditches and drainage features carried water away. In many cases, the road was not just a surface. It was a shaped structure designed to be dry. Dryness is durability. Then come the layers. A Roman road wasn't one slab thrown onto dirt. It was a layered system: large stones or rubble in the foundation, then smaller stones and gravel, then finer material, and finally the paving stones on top. The exact layers could vary depending on region and resources, but the philosophy remained: distribute load downward, prevent movement, and lock the structure in place. And to make layers work, you need compaction. Compaction is the unglamorous secret behind durability. A road fails when the ground underneath settles unevenly. The Romans understood that if the foundation moves, the surface will eventually break. So they built foundations thick enough, packed enough, and structured enough to resist movement. And when you combine good foundations with drainage, the result is simple: the road survives. The Roman road recipe: survey, layers, drainage, compaction. If you strip away the legends and look at a Roman road like an engineer, it stops being mysterious. It becomes ruthless. The secret isn't a magical material. It's the way the Romans treated a road as a complete structure, like a fortress laid on its side, built to stay dry, stay compact, and distribute load for decades before the first serious repair. And it starts with something modern people underestimate: the route. Roman roads weren't straight because the Romans were obsessive artists. They were straight because the Romans were practical planners. Shorter routes reduce travel time, reduce fatigue, and simplify logistics. Straight lines also reduce complexity in construction because you avoid unnecessary turns and unstable ground where possible. But straight doesn't mean stupid. Where the landscape forced compromise, marshes, river valleys, mountains, the Romans adapted with engineering solutions: embankments, causeways, cuttings, bridges. They didn't treat terrain as an excuse to abandon control. They treated terrain as a problem to be solved. That required surveying. Roman surveyors weren't improvising with guesses. They had dedicated tools and a professional culture. They measured alignments, set markers, and controlled gradients as well as the landscape allowed. That matters because route choice determines drainage and stability. If you choose the wrong line through wet ground, no surface, Roman or modern, survives for long. So once the route was chosen, the next step was ground preparation. In many cases, the Romans didn't just lay stones on top of whatever soil existed. They excavated and prepared a base. They understood that a road is only as stable as what it sits on. Then comes the layered structure, the part everyone loves to describe because it feels like a recipe. The names and exact compositions varied by region and time, but the logic remains consistent across many reconstructions and archaeological findings. A Roman road was built as a thick, multi-layer system designed to lock itself together. At the bottom, you start with large foundation material, big stones, rubble, or heavy aggregate, something that provides a stable, load-bearing base. This layer is not meant to be smooth. It's meant to be immovable. It spreads the load and resists settlement. Above that comes a layer of smaller stones and gravel, material that fills gaps and creates a tight interlocking bed. Above that, a finer layer: sand, fine gravel, or crushed stone, creating a leveling surface that supports the paving. And then, at the top, the visible surface, paving stones carefully fitted, or in some regions a compacted gravel surface, depending on the road's importance. This is the engineering idea behind it: load distribution. A wheel or a foot applies pressure at the surface. If the structure underneath is thin or weak, that pressure creates localized sinking. Local sinking creates cracks. Cracks invite water. Water destroys roads. Roman layering spreads pressure downward and outward, so the ground does not deform in one spot. But layers alone are not enough. The real killer detail is compaction. Compaction is boring to talk about, but it's where roads live or die. If you don't compact each layer well, the road will settle later, and settlement becomes cracks. Once cracks exist, water enters. And once water enters, the road begins its slow collapse. The Romans built roads in a culture that valued discipline and repetition. The same culture that drilled soldiers to march in formation could also organize labor to compact and fit stones with consistency. Even without modern rollers, compaction can be achieved through persistent labor. Packing, tamping, fitting materials tightly, and building thick enough that the structure stabilizes. Now add the factor most people miss: drainage geometry. Roman roads were often crowned, higher in the center, sloping toward the sides. That crown matters because it prevents standing water. Standing water is death. Water must move away quickly. And the Roman road system was built around that rule. So you don't just build a flat surface. You build a surface designed to shed water, then you build side ditches to carry water away. In many areas, the road was raised on an embankment so even heavy rain could flow out and down rather than pool in the structure. This is why the headline, "Engineers Still Can't Replicate," is both true and misleading. Modern engineers absolutely understand crown, drainage, and layers. But modern roads often fail because drainage is compromised by poor maintenance of ditches, clogged culverts, surface cracks left unrepaired, or the constant intrusion of utilities and repeated trench cuts. The Roman road model worked best when the structure remained continuous and the drainage remained clear. Roman roads were engineered with fewer interruptions. They were also maintained in ways that modern people rarely compare honestly. Rome treated roads as strategic assets. That means there were systems, formal or informal, for inspection, repair, and keeping roads passable. A road that lasts centuries is not simply a road built once. It's a road kept alive. So what's the real secret? It's that the Romans built roads like long-term infrastructure by default. Thick layers, strong foundations, aggressive drainage, and a cultural willingness to invest labor in compaction and maintenance. Modern infrastructure often has different constraints, limited budgets, faster construction demands, heavy trucks, asphalt economics, underground utilities, and political pressure to build quickly. We can replicate Roman durability, but we often choose not to pay for it everywhere. The real enemy was water. How Roman roads stayed alive. If you remember one thing about roads, remember this: most roads don't die from weight, they die from water. Water is patient. It doesn't need to destroy a road in a day. It seeps into the smallest gaps, softens the soil beneath, freezes and expands in cold weather, loosens stones, creates tiny voids, and slowly turns a stable surface into a cracked skin. Once cracks appear, more water enters, and the collapse accelerates. This is why Roman roads feel almost supernatural in their survival. The Romans built with a rule that modern people often ignore until it's too late: keep the structure dry. And that is why the famous Roman road, secret, is not a mystery ingredient. It is drainage geometry plus discipline. Start with the shape. Roman roads were often built higher than the surrounding ground, sometimes on a raised embankment. This elevation matters because it gives water somewhere to go. If the road is lower than the land, water collects. If the road is higher, water flows away. Then comes the crown. A crowned road is higher in the middle and slopes down to both sides. This does two things. First, it prevents puddles from forming. Second, it pushes water toward the edges where it can be collected and carried away. Now add ditches. Ditches are not decoration. They are the exit system. Water that leaves the surface must be guided away from the structure and away from the foundation. If water sits near the edge, it can soak into the base and weaken it from the side. A good ditch makes sure water leaves the road environment entirely. This is why many Roman roads were not just paved strips, but whole engineered corridors, road surface, shoulder, ditch, and embankment working as one drainage machine. In some places, Romans also used culverts and small channels to move water under the road, especially where natural water flow crossed the road. The goal was always the same: do not let water sit inside the structure, because once water invades the structure, it destroys compaction, and compaction is everything. A road is stable when its layers are tight and interlocked. If water softens the soil beneath or washes fine material away, voids form. Voids allow settlement. Settlement causes cracking. Cracking invites more water. It becomes a loop. Roman road design tries to break the loop at the beginning by forcing water out. This is also why Roman roads were thick. Thickness is a stabilizer. A thicker structure distributes load greater and resists small ground changes. If the top layer shifts slightly, the deep base can still hold. Thin roads are fragile, thick roads are forgiving. Now, this is where the myth of modern engineers can't replicate it often comes from. Modern roads are often built with asphalt layers over compacted base, and they can be extremely durable when constructed and maintained properly. But modern roads are also constantly attacked by things Romans didn't design for. In the same way, repeated trench cuts for utilities, heavy truck loads that create rutting,